Top right-hand corner, put your date. What is today's date? 9/7,
It's the ninth.
or I'm sorry, 9/9/13. That's right, good, you're paying attention. Real numbers and number lines. Section's not too bad. It's really just a lot of, really a lot of review.
Bless you.
Let's review some of these different types of numbers, whole numbers. In a lot of ways, the easiest way to define them is to make a number line. Whole numbers are 0, then what? Anybody remember? 1, then what? 2, 3, 4, and then I'm going to color in the arrow to indicate so on and so on with the same pattern. It's not any fractions, it's not the numbers in between. It's 0, 1, 2, 3, 4, so it doesn't include negative numbers. Do the whole numbers include negative numbers?
No.
No, they do not. Natural numbers.
Let's see.
All the whole numbers except 0. So it'd be the same picture as this, except what would I not color in?
0.
Very good. Integers. Do you guys remember what integers are? You guys remember what the integers are? Well, the integers are all the whole numbers. So I'm going to color in all the whole numbers. That would be 0, and then all the positive numbers that aren't in between. Okay? That's the whole numbers, is it not? Does anybody know what the integers also include? The negatives of each whole number. So take all the whole numbers, put a negative sign in front of them, and that's what the integers have that the whole numbers don't. Same pattern, so on and so on. Real numbers. Does anybody know what the real numbers are? They're the integers and all the numbers in between. So they're all those, aren't they? Rational numbers. This is harder to write on a number line. You just have to define it. A number that can be written in the form A over B. Where A and B are integers and B cannot equal 0. Is that a little more complicated? Yeah. Because it forces you to kind of visualize what they are. Irrational numbers are numbers that cannot be written in the form A over B. So on and so on. Same as before, except here they can be and here they what? Can't. Now, here's the thing about irrational numbers. It's hard to define. Something I can help you two with?
Me? Say you can help me. I was trying to see his notes because you was going a little fast. I didn't get the first one.
Okay. Which one?
Oh, I got it now. He did not give it to me.
Okay. Irrational numbers. Here's the thing to remember about them. Non-terminating and non-repeating decimals. Can anybody give me an example of non-terminating, non-repeating decimal? One example would be pi. You guys have heard of the number pi, right? It's a non-terminating, non-repeating decimal. That's what makes it special. Okay? What do we mean by repeating? Doesn't repeat the same pattern.
Like it doesn't do 5 0 5 0 5 0.
Right. Doesn't do 1 5 1 5 1 5 1 5 5 0 5 0 5 0 like what she's saying. Okay. You know, like 1/3. You guys should remember what that decimal is. What is it? 0.3 what? Repeating. Right. That's repeating. It goes on forever. It's non-terminating. That means it goes on forever and ever, right? But it repeats the same pattern. Well, if it repeats the same pattern, it can be written as a fraction. So that's a rational number. Okay? So if it repeats the same pattern, then there's some way to write that as a fraction, whatever it may be. However, if it does not repeat the same pattern, and it doesn't ever stop, then it's irrational. Basically, there are some special numbers. Another example, square root of 2. One number squared is 2. Well, you put that in your calculator, you're going to get some number that doesn't repeat and doesn't terminate, okay? Square root of 7. Not a perfect square, that does not repeat. Now, an example written in decimals, like what we're going to do in this chapter, they say, give me an example, a 10-digit example of an irrational number to 10 decimal places. Well, obviously it's irrational, it goes on forever, right? So I could say 3.4592337 1 2 3 4 5 6 7 3 8 1 1, 2, 3, 4, 5, 6, 7, 8, 9. How about 1?
1.
It doesn't matter. Did I repeat any pattern there?
No.
Okay, that would be an irrational number between 3 and 4. Taken to 10 decimal places. Does it keep going? Yes. So in essence, we should put the dot, dot, dot on it, shouldn't we? But see how it doesn't repeat the same pattern? An example of a rational number, 3.1313131313. That's taken to 10 decimal places between 3 and 4, right? They'll have questions on your homework like, give me an example of a rational number taken to 10 decimal places between 3 and 4. Okay? Or an irrational number to 10 decimal places between 3 and 4. You see what I'm saying? You see how you do that? It's not so bad, is it? Non-terminating means doesn't stop. Non-repeating means it doesn't ever repeat the same pattern. Has everybody got this down? I need to freeze this for a second, don't I? Okay, I'm going to start on a new sheet of paper. We're going to talk about, and we're going to draw a big number line. And we're going to talk about measuring distances on the number line. Okay. We're going to do some examples. But first, we're going to have a rule to find the distance between 2 points on a number line. Simply subtract the coordinates. The absolute value. Why would I say absolute value? Right. Distance, when speaking in terms of distance or things like that, when you're talking about, when you use a negative, that means direction. We're not dealing with direction here. We're dealing with how far is it. Okay? So what we're going to do is your examples, we're going to find all of these. If you wonder why I'm writing them the way I'm writing them, why did I make a big deal that when you talk about segment AB, you put a segment above it? This is why. Anytime you put 2 points beside each other without anything above it, eyes up here. See how I have AB? That's not talking about the segment A to B. When I don't put anything above it, I'm saying this means the distance from point A to point what? B. When I don't write anything above it, that's what that means. Okay? that's just like knowing a language, knowing that THE means what? The. You've never saw English before, you look at me like I'm crazy, yeah, big deal, that's easy. But if you've never spoken English before, would you have any idea what THE meant? No. Pretty simple concept once you get it, right? Simple concept here, whenever you don't write something above the AB, 2 points beside each other, in geometry you're denoting the distance from one point to the other. So this represents a number. So to find AB, I'm going to take the absolute value, I'm going to subtract their coordinates. Now here's an important thing here. Now, as much as you guys, and I know, hold, everybody stop writing, and we'll do this together and then I'll let you write it down. I know that every single one of you here can count marks. Agreed? I realize that. But that's, of course, not how I want you doing it. I want you subtracting the coordinates. The reason? Understand that a lot of times in math and stuff, we'll do things in a very simple setting. They could be done an easier way. But the reason we're doing it in a simple setting is so you can see the concept of what we're doing easier. I mean, do any of you want to write out a number line of negative 1,243 as one coordinate and 1,846 as the other? Do you want to count those marks? I wouldn't think so, would you? You'd rather subtract the coordinates, wouldn't you? So, we need to know how to do this. So, what are the coordinates of A? A is at what? Negative 4. Now, pay attention. What is B at? I'm going to write negative 1 in here. What jumps out at you? I'm subtracting. This is minus a what? So what does this actually become? Minus 4 what? Plus 1. Absolute value of that is a what? Or the negative 3, and the absolute value of that is what?
3. Why did I say 5?
3 is your answer.
Because you're crazy.
It's okay. Not too hard. Hey, guys, don't write this down. I said wait till we're done, then you can write it down. AC is equal to. Remember, I'm going to write the 2 coordinates down and subtract them. So my subtraction's already in the middle, right? What are the coordinates of A?
34.
You guys think this is easy, but you'll do this wrong if you don't pay attention. What are the coordinates of C?
45.
1/2, or 0.5. Together, that becomes an absolute value of a negative what? 4 1/2, correct? Which becomes a positive what?
4 1/2.
4.4 and a half. Said 4 and a half.
BD. Remember, I'm subtracting them. What are the coordinates of B?
Negative 1.
What are the coordinates of D? Huh?
2.5.
Positive 2.5?
Mm-hmm.
So I'm left with a negative what? 3.5? Which is a positive what? A to E.
Negative 4.
Remember, I'm subtracting them, taking the absolute value. I've got negative 4 is this one. What's my other one? 4. Together, that makes a negative what? 8. Absolute value of that is what?
8.
Write that down. I think we're going to end up getting around to the... After you're done with that, get your worksheets out.
When do you need that today?
Yes. We'll look at numbers 1, 2, and 3.
with that. No.
Okay, we ready? Can I unfreeze this? Okay, we've got this first one out here. It says we're gonna take, each situation, write a real number with 10 digits to the right of the decimal point. Okay, a rational number that's less than 0 with a 3-digit repeating pattern. So it's gotta be less than 0, so what does that mean it's gonna be? Negative. Right? It's less than 0. It's rational. 3-digit repeating pattern. You guys wanna make negative 2 point. Give me our 3-digit repeating pattern. Huh? All it has to be is any 3-digit repeating pattern. Think of 3 letters, numbers you want me to repeat.
173.
I heard 173, and then we'll go 173, 173. They want how many? 10 digits, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. What would be the next one? 1. Dot, dot, dot. So I've done all the requirements, haven't I?
Mm-hmm.
It's less than 0. I have 10 digits to the right, and it's a 3-digit repeating pattern. Everybody's kind of, for some reason, everybody freaks on these because they have to be creative. Oh gosh, what if I pick the wrong 3 numbers? Ask you to pick 3 numbers. Now, would 333 be a 3-digit repeating pattern?
No,
That's
no.
1-digit repeating pattern, isn't it? You see what I mean? So obviously it's 3 different. There are ways to do it incorrectly. An irrational number between 7 and 8. Well, really the only way you can write that, it's between 7 and 8, so isn't it 7 point something? So what do I need to do? Go 10 digits, and what needs to not happen? The pattern does not need to repeat, right? So 1, think of another one.
2, 3, 4,
2, 3, that's a pattern though. Think of something else.
6.
It's a pattern?
6,
6.
4,
4,
7.
7.
9.
Let's go with 1. See, so it shows that it's not a repeating pattern. Do you see what I'm saying? 1, 2, 3, 4, 5, 6, 7, and then go, what'd you say, 8?
8.
1, 2, 3, 4, 5, 6, 7, 8,
9. Oh, wait, no.
9, and then what?
2.
2, dot, dot, dot. See how that is not a repeating pattern? Now, if you had gone 1, 2, 3, 4, 5, 6, 7, 8, 9, and then gone back to 1, isn't that a repeating pattern? You see what I'm saying? So you got to be random with it. And the best way to show random, and let me show you, what showed that this was a random pattern?
1 repeated.
When I did the 1 the second time and put what behind it?
8.
Instead of,
2.
see what I mean?
Oh, I thought it was because you put 3 and 6.
No. You see what? Do you guys see what I'm saying? Now, if I could have gone 1, 2, and then 9, then at that point, when after the 2, there doesn't come a what? 3, the pattern doesn't repeat, does it? Okay? 2 irrational numbers between -1 and -2. So -1 point, we're going to take it to 10 decimal places. Tell me numbers.
4.
7.
9. Oh.
I'm waiting.
4.
I heard 3,
4.
4,
6.
6,
7.
7,
1.
1,
5.
5.
7. So my hair is big.
Heard 7 again. What else?
4.
There's 10. Dot, dot, dot. Okay. That's not a pattern repeating, is it? It asks for 2 of them, though. So my second will be -1 point. Give me numbers.
6.
Then what?
2.
4.
7.
9.
6.
3.
8.
8.
5.
And 4 called them.
What's next?
4, 2. Nope.
We're okay, got 10, don't we? You see how that's something, as hard as that sounds, when it's all said and done, that's awful easy, isn't it? See what I mean? It's not so bad. Everybody look at number 12. Detroit, Michigan, the weather report says that the high was 3 degrees Fahrenheit with a wind chill factor of -10. Find the measure difference between the two temperatures.
Can you survive temperature?
Yes. It's just not very much fun. You better bundle up. Trust me, my mom grew up in Michigan. It's cold. Now, so basically, you're at +3, and then over here you're at -10. If you were to put that on a number line, what would the distance be between them? It'd be -10 minus what? That's basically, and you get -13, but distance is always what?
Positive.
There's 13 degrees in between them. What did I basically do? Subtract the two coordinates, didn't I? Pretty easy, huh?
Pretty easy.